Hi, welcome to another video from SQL Maestros, and today I'm going to talk about page splits and fragmentation. This is an age-old topic, and you will have a lot of information over the internet talking about how bad page splits are and how bad fragmentation is for your index. And of course, the direct result is the query performance is so bad when you have a lot of fragmentation. So before I jump into the demos, let me first explain you the concept behind page splits and fragmentation. When you create a table, it's a heap, which means there is no index. Specifically, there is no clustered index. A heap is a table with pages, and those pages are in no specific order. So I would not really say unordered, but I would just use the term that they have no specific order. It's like bunch of pages just lying on the disk. And when you want to retrieve data from that table, there's always a scan on that table, and all the pages are always touched. When you create an index on that table, let's say you have created a clustered index, then the pages of that table are supposedly to be sorted by the index column. So let's say you have a sales order table and you have a column called sales order ID, and you create a clustered index on sales order ID. And now the data is going to be ordered by sales order ID in ascending order by default. And of course, when the data is sorted, the pages are also going to be sorted by sales order ID, which means, let's say, each page belongs to a specific sales order, just for the purpose of explanation. So you have sales order ID 1, and then next to 1 you will have sales order ID 2, and then next to 2 you will have the sales order ID 3. So that's how the order goes. Now, page splits and fragmentation, this concept is like chicken and egg as to which one do I explain first. So a couple of things can lead to fragmentation. So let me first explain you what is this fragmentation concept, and then I will talk about the causes. Fragmentation is, as I said, the clustered index. The pages are in order. Fragmentation is when these pages are not in order. When you create a clustered index, what also gets automatically created is what we call as the linked list. Linked list is logical in nature. What do I mean by that? Every page, let's take a page. I didn't plan this, by the way. Okay, this is an old certificate of people who are in India, but anyway, I can use it. Every page has a previous page pointer and a next page pointer, which means, like, because this is supposed to be in order. So let's say this is sales order ID 2. The previous pointer will point to page order ID 1, and the next page pointer will point to sales order ID 3. And if you see, with the help of these pointers, logically a linked list, because they're linked, these pages are linked to each other, a list is being formed. Now what happens, let's say for whatever reason these pages go unordered, which means next to 1 you have 5, next to 5 you have 10, next to 10 you have 3, so on and so forth, which means they're all in different order, but that pointer is always there. The pointer will always say that, after 2 I expect 3, and after 3 I expect 4. That linked list is always in so-called order because it is logical in nature. But physically the pages on the disk could be in different order. They just could be scattered, and that is what we call as fragmentation. So using the popular DMV, DM physical stats, index physical stats, when you look at the statistics, you will see percentages fragmentation like 30%, 60, 80, sometimes even 99% fragmentation, which means the pages are badly ordered or unordered. Now, what happens when you want to retrieve data, and why is fragmentation bad? Because when all these pages are not in order and they're just scattered on the disk, and you want to retrieve data, let's say you say select star from this table. Now, because you say select star from this table, you are not asking SQL Server to give you the data in any specific order. So SQL Server can just start reading the pages the way it gets it, the disk. So whichever order they are in, it will just start picking it up and will render it back to the client. So that's fine. But the moment you say select star from this table, order by, and when you say order by the same clustering key column, with which you had ordered. When you say order by, now SQL Server is supposed to get you the data in ordered fashion. Then it's going to follow the linked list. Then it's going to go to page 1, and then it wants page 2, and then when it goes to page 2 it wants page 3, but page 2 and page 3 could be scattered somewhere in the disk. And then now what happens, the disk read write head has to move from sector to sector to get the data out from the disk. And in a magnetic disk, that takes time. So that is really the problem of fragmentation. So specifically in magnetic disks, because those are moving parts, and because the data could be scattered and it's not in an order, and you want the data in ordered fashion, fragmentation can lead to poor query performance. So that's the whole problem with fragmentation. Well, with a lot of advanced IO now coming into enterprises, enterprise storage, and like the flash disks and the SSDs, the problem of fragmentation has obviously reduced, because when you talk about an enterprise storage and there is no moving part, because SSDs are gaining their entry into enterprises and it's becoming more common, then fragmentation is not too much of a botheration, but it still bothers. And this is what I'm going to show you in the demo. So hold on for the, let's wait for the demo for the time being. But now let's understand fragmentation. How is it caused? When one of the reasons how it gets caused is because of page splits. Now page split is another phenomenon that happens inside the database engine. And what does that really mean? In simple terms, this is a page and there are multiple records in this page. And let us say you want to insert another record in this page, but the page is really full. There's no space. And it's not that you want to insert a record, because you don't decide where the record will go. SQL Server will automatically decide to which page the record goes. But let's say this is the same table sales order ID, and for whatever reason, you are going and want to insert a backdated record. Let's say there was an accounting issue or something, and you want to go and insert a backdated record, which means the sales order ID could be somewhere in between, lesser than what it is right now. What I mean is, sales order ID is supposed to be in a serial fashion, order ID 1, 2, 3, 4, but there are gaps somewhere in between, and you want to fill those gaps for accounting reasons. So let's say you already have 100 orders and you want to insert sales order ID 45. And now because the data has to be physically sorted with order ID, with the sales order ID, 45 has to go to the correct page based on the order. But then let's say it has to go into this page, but this page is already full. So what will SQL Server do? SQL Server will split this page into two, and the original page stays where it is, and the new page goes to the end of the file, which means it's a new page, so it gets allocated at the end of the file. And now there's space being made in this page. So 50% of the records will remain in the original page, and the remaining 50% approximately will move to the new page. And now that you have space here, the record sales order ID 45 will get inserted. But now what has happened? 45 gets inserted here, assuming that there was 44, 43, 42, 41 obviously in this page. But what about 46, 47, 48? 46, 47, 48, 49 have gone to the new page. And now you see that they are not in order, which means after 45 you immediately now get, let's say in the new page, 50, 51, 52, but then those remaining 5 have gone to the new page. So that is now adding to fragmentation. So page splits is the most common reason why fragmentation occurs. And there are all sorts of reasons how you can avoid all sorts of solutions as to how you can avoid page splits. There are best practices, there are things that you should do and you should not do, etc. Well, that's a huge topic, and that can really take more than half a day. But then with this quick demo, what I'm trying to show you that how does page split occur. And of course, while I'm showing you the demo, I will definitely talk about a few best practices and do's and don'ts. So I will show you how page splits happen and how page splits lead to fragmentation. And now what I will also show you that, the common debate that is going on, do you really need to bother about fragmentation with solid state drives, all these SSDs that are coming in, which are super fast? Do you really need to worry about fragmentation? So I am going to show you that yes, in some cases you may not have to worry, but there are cases where you may have to worry about fragmentation. And this is what I want to show you with the demo. So I hope the concept is clear, and of course you have a lot of information on the internet to read more about page splits and fragmentation. I'm sure this quick 5 or 10 minute conceptual explanation wouldn't have been good enough, but yeah, that's how it is. You want to insert a record into this page, but there is not enough space, but the record has to go into this page because of the order. So SQL will split this page into two, causing a page split, which also is an expensive operation internally for SQL Server. And because it splits it into two, 50% of the data approximately is moved into the new page. The new page is somewhere at the end of the file, and that leads to fragmentation. And when there is fragmentation, pages as the percentage of fragmentation increases, which means more and more pages are in unordered fashion, and retrieving those pages, especially when you ask those pages to be retrieved in an ordered fashion, that takes time on a disk with moving parts, because then you're instructing SQL Server that I want to read the data in an ordered fashion. So that's page split and fragmentation. And now let's jump into the demo. And now, without any further delay, let's jump into the demo. Let's get started. I'm going to use TempDB for the purpose of this demo. And in TempDB, I am going to create a table called T1, and T1 will have two columns, CLC1 and test data, these two columns. And you will notice that purposely I have put this first column as unique identifier data type, and it's a no-brainer that every new GUID that's going to be created using this function new ID, there is no guarantee that the GUID will be higher or lesser in value with compared to a previous GUID. And I would purposely cause splits and fragmentation using this technique because I'm going to create a clustered index on this column C1. So let's go ahead and create the table. And just to repeat again, remember I have created this particular column C1 with the data type unique identifier. And as I insert records, the new ID function will generate GUIDs. And because the data is supposed to be physically sorted by this particular column, the every new GUID that is generated, there will be no guarantee that it's going to be higher or lower than the previous GUID. So that may cause a lot of splits and fragmentation. And next what we are going to, okay, of course, let me just turn out the no count because I'm going to insert a lot of rows. And this is a simple statement that I run to insert the data, and I'm going to insert about 100k, yeah, so about 1 million rows is going to be inserted into this table. And a lot of as I said, splits will happen now. And also one more thing that I just missed out is, look at this one. The second column is of char, approximately 2000 bytes there. That's purposely done there because I just want to create a lot of pages actually, and I want to just fit in about 4 rows in each page. Even though the data that I'm pumping in SQLServerGeeks.com is very small, I still want to just, because this is fixed length. This is fixed length data type, which means I will, irrespective of the value or the length of the value, I will always occupy 1950 bytes on the page. And I purposely do that just to fill pages quickly and get a lot of pages. And let's run this statement here. And while this is running and it started, I'll launch perfmon and go to performance monitor quickly. And I need to do that because what I want to show you is page splits happening now. And remember, there's the better way of doing this or showing this to you is extended events. But I want to tell you prior to extended events days what we used to do. So I'm going to go to my instance, and there is a object here called access methods, and that's what I'm trying to access methods. And if I scroll down, there will be page splits per second, which will just give you the count as to how many splits are happening on per second basis. And you can see a number like 3000, 4000, right? 4500 page splits are happening on per second basis. So that's a pretty big number there, you know, all these numbers that are coming in. So of course it is expected, those many page splits, because remember, 4 records going into every page, and then because GUID value could be higher or lesser, it just goes and splits into the page, the same concept that I had explained. And then you have a new page getting created which goes at the end of the file, and that's like going on and on and on. So yeah, a lot of page splits there. So I'm also going to record another video. I mean, you may find this in the channel already if I've done it, where I'm going to show you how to track page splits using extended events. The problem with this counter is, while this counter gives me a number, it's difficult, or it's kind of impossible to find out which workload or which query is actually causing it. So all these high number of page splits that are happening, who's causing it, which session, which query, which workload, which stored procedure. I need to find that out, and extended events is the best way to find that out. So watch out for another video in this channel where I will show that to you. But for the time being, let's stick to index tuning, and let's stick to page splits and fragmentation. So a lot of rows inserted, about 10 million or something, 10 million and one maybe, because I started from 0. And if I want to fetch all the data, then of course it's going to take time, but this is what I'm going to do now. So I will turn on statistics IO and time to show you the performance. And now in this this hardware, I do not have magnetic disks. I have SSDs, and that's the point I was trying to make, that with SSDs and with small data like a million, the performance degradation is not evident. But still, I'm going to show you how it is evident and when you should care about it. So now if I run dbcc drop clean buffers, because I want to remove everything from the cache, and now if I say select start from this table, this is actually going to cause index allocation scan, which means I'm not really bothered about the linked list. I will just go and fetch the data in any order it is on the disk right now. So this is really asking the data in any fashion, whichever page is available, just bring it up. There's no specific order. So let's go and run this and see how much time it takes. So and I don't need to really go into the execution plan, because the purpose is not execution plan, purpose is how much time this has taken. So select star from the table, and now you start getting all the data, about 1 million records. So you can see all the GUIDs out there, and this is the second column data. And remember, this was fixed character length, and this was the GUID, and this is still running and may take about a few seconds. And of course the point that I'm trying to make here is that this select, and then this is going to be unordered, and when I look into the ordered one, when I want to get the data in ordered fashion, that is where you will see or whether we want to find out whether there is any performance difference or not. So this is still fetching the data. Let's wait for some time. And while this is going on, I can actually copy this one and show you in another window what is the fragmentation level right now for this object T1. So if I execute this, you can see the fragmentation is 99%. That's the max you could go. 99 point something. And as I said, this is purposely caused because of having that GUID and creating a clustered index on GUID. So remember, there are certain best practices with clustered index, that it should be narrow, it should be ever increasing, it should be using a small data type, so on and so forth. So of course, none of those best practices were followed, and that resulted in this dangerous number, 99% fragmentation. So, well, that was expected, 99% fragmentation. Let's go and see. Okay, so the query completes and you get all the data, about 1 million plus 1 row, and how much time this has taken. So if you see, it has spent about CPU time, about 10 seconds or so on the CPU. So let's not bother about the elapsed time, because that's the time it has taken to render the entire data set in Management Studio. We should be focusing on the amount of time it has taken on the CPU, about 10 seconds or so. Now let's go and clean the buffers once again, and so we've freeze, and now I want to get the data in ordered fashion. Now this is interesting, because now I'm telling SQL Server that give me the data in an ordered fashion, and because the order, and I also say order by that specific column C1, so it has to go and fetch the data in an ordered fashion. And because the fragmentation is already 99%, the data is scattered on the disk, this might take time. But here is the catch. The catch is, does it really take more than 10 seconds, less than 10 seconds, or more or less the same time? And you will be able to see the difference, because now this is an SSD. Had this been a magnetic disk, the difference would have been in multiple magnitude. But now because this is SSD, there is no moving part, this is going to go very quick. So let's do that, and then I will show you another query where fragmentation does play a key role, and how does it impact performance. So let's go, and I think I ran dbcc drop clean buffers. Yes, there you go. And for this, I should also turn on actual execution plan, because I just want to show you that ordered thing. And yeah, statistics time is already on. So let's go and execute this. And remember, the fragmentation is still 99%. We haven't rebuilt or reorganized the index at all. So this is the DMDB index physical stats, very popular. And I have a few parameters there, the database, the object, and this is important. This one or this one, we'll see that where you're asking for sampled or detailed when you're running this. And I'll just show you, there's a small catch to this as well. So when you execute this, yes, it is still 99%. The data is still coming in, and it might just take less than a minute. So let's wait while all the data comes out. There you go. And now okay, is it done? Yes, this is done. So how much time has this taken? Let's go to the messages tab. Wow, and this has taken less time. CPU time is lesser than previous one. So you would see, okay, fragmentation doesn't really matter, right? But yes, it does matter, and I will show you in a while. So let's go and look into the execution plan, and now you can actually see that ordered was set to true, while in the previous case it would have been false because we didn't ask for any specific order. Now the point is, this one runs faster, but then this is not really the benchmark, and this is not the point that I'm trying to prove. In both cases, here with fragmentation, the ordered and unordered retrieval is just kind of same. But now comes the point. Let me drop the clean buffers again, and now I will do an update, and now you will see the impact. So let's do select top 10, and I'll just get one of the keys there, the GUID, and let me copy this and go back to the query and paste it here. And now what I'm trying to do, I'm trying to do a mass update. I'm trying to tell SQL, okay, let's change this to sqlmaestros.com. okay. And so SQL Server Geeks is my community work, and SQL Maestros is my professional day job. That's where the difference between the two .coms is. Anyway, back to the code. So now what I'm trying to do, I'm trying to update T1, and I am saying set clustered, what is this column? Yeah, test data column to sqlmaestros.com. And now here is the difference. When I run this, let me just remove this so that, okay, now this would mean what? This means a mass update in any order, and we will see how much time it takes. And okay, let's do it this way, and to be more fair, let's first do it in an ordered fashion. Okay, so I'm saying update all the records where with this new value, and I say where column 1 is greater than this GUID. And let's drop the clean buffers, and let's be realistic, whatever time it takes. And this is an ordered update that I'm trying to do now. And let's record how much time this one takes. So remember, I'm also even reducing the number of characters. So sqlmaestros.com is smaller than SQL Server Geeks, but then that's not too important to focus on. We want to see how much time this one takes. So let's go and execute. And now you will see the data is still fragmented, and this is what you want to do. You want to record the performance of the update, this mass update that is going on with fragmentation and without fragmentation. And yes, just to be sure, I have not defragged this object. Okay, so update is going on, so this is going to get blocked now. So let's just wait for some time and let's see how much time this one takes. What about page splits there? I can close this window, not required. So the update is still going on. It might just take a few more seconds. So this is also going to update close to a few hundred thousands of rows. And remember, I just randomly took something. Okay, so about 1 million rows get affected there. And please record this CPU time. This has taken about 43 milliseconds on CPU and 53 seconds overall. And let's just record this much. And I'll just put it down in a notepad there. Or why notepad? I can just open a query window and paste it here. Okay, let's keep this. And what I was trying to show you, this was the update that we did while there was so much fragmentation. And because now when you say greater than something, then this is an ordered update. And now I will go and rebuild the index, and rebuilding is as good as dropping and recreating it. And then the index is going to be defragged. So let's go and do that. Might just take a second or two. Yes, it does. And let's go and verify what fragmentation do we have now. And let's execute this. And there you go. This is what you want. This is perfect. And you have like almost 0% fragmentation now. And earlier it took about 43 seconds. Let's go and do this update once more. So to be fair, drop clean buffers because you don't want the data to be in cache. And let's change this back to SQL. No, this time I will change it to dataplatformgeeks.com. So these are two communities that I work with, SQLServerGeeks.com and dataplatformgeeks.com. And update T1, and this time we are again doing the same update and the same GUID, nothing else changes, and order data, but this time the data is fragmented. Oh, sorry, defrag, which means the pages are in order and you want to see the performance. Let's go and execute this and see how much time this one takes. And of course, this is going to also update the same number of records. Wow, and this is superb. And look at this now. This has just been done instantly almost. So it has taken 5 seconds, 43 seconds versus 5 seconds. So even though, so the point that I'm trying to make, that even though you are on SSD, please make sure that you do not have such high fragmentation like 90 or 99% or so, because even if you are happy with your select performance, your updates and ordered updates, etc., they all go pretty cranky, and that's what you want to care about. So that was a quick demo on page splits and fragmentation. And remember, fragmentation was caused by page splits because of this GUID. So there's so many different learnings from this demo, and I'll still tell you that this topic is not over as yet because it's a huge topic and there's just so many things here. With this, thank you very much. Hope this video was worth your time. See you soon in another video.